Hello and welcome everyone to my channel Code with Ease. So today as part of the array series, we have come up with another question which is called how to find the squares of a sorted array. So we are given this integer array nums which is sorted in a non-decreasing order and we have to return an array of the squares of each number, but they should be sorted in a non-decreasing order. So this is the input array that we have, in which the numbers are starting from a negative number, and this is the output. So as we can see, the output contains the squares of every number that we have in the original array, but not in the same order. Rather, the output is itself sorted in an ascending order. So now let's discuss what should be the way to solve this. So now let's discuss the approach for solving this question. We can start with the brute force way of solving. What is the initial thought process that we have? We have to return an array which will be composed of the squares of the given numbers that we have in the original array, and that array itself should be returned in a sorted order. So the initial thought process would be, let's generate the squares of every number. So if we have, this is the array with us, let's generate all the squares. So we have 16, 1, 0, 9 and 100. These are the squares of the original array. And then we can use this arrays.sort and we can get the answer in the required format. What is the time complexity of doing this? First of all, we have to traverse to the array to generate all the squares. And then we have to do arrays.sort, which has a time complexity of n log n. So although it is not an exponential complexity, but it is also not as efficient as order of n time complexity. So we will have to try to optimize this to try to solve it in order of n. So like we discussed, that the brute force way of solving is going to give a complexity which is not as efficient as order of n. So we will try to optimize this. So this is the array that we have. Now earlier we were first trying to find out the squares and then trying to apply a sorting logic on that, a built-in sorting method on that. Instead of that, what we can do is we can use an algorithm which is the two-pointer algorithm. So we can have one pointer over here, the start, and the end pointer over here. Or I can just say, if you notice this output array closely, and if we start from back, we see that the output array is anyway needs to be sorted in a ascending order, which means the greatest element has to be at the last. So that is like the basic observation. The next thing what we have to observe is, if given an element, next thing what we have to observe is, given an element, whether it is a negative number or it is a positive number, like whether we have -3 or whether we have 3, the squares of both are always going to be the same. Okay. So next thing what we can observe, if any given number, if the given square has to be the greatest, which means the corresponding number which generated the square is also greater. What I mean to say is, let's say I have a number which is -4 and I have a number which is 6. So -4 square is going to give 16 and 6 square is going to give 36. 36 is definitely greater than 16. If it was 4 also, then also it would have been 16. So irrespective of the sign of the number, greater the number, greater the square. So using this logic, what we will do is, since now we have these two pointers, the start and the end, we'll start from back. So we are going to start from behind, and what we are going to do is we are going to take one additional array, and then we'll start we'll check whether the absolute value of the pointer which is pointed by the start and the absolute value which is pointed by the pointer which is the end, if whichever is greater. So in this case, as we can see, that 10 is greater than 4 because absolute of -4 is 4. So if 10 is greater, so square of 10 will be greater. So whichever is the greater, whichever square is the greater, we are going to put that at the end of the array, the new array. And then we are going to adjust the pointer accordingly. So since we are done with this already, we'll move end minus minus. Then we'll again compare start and end, which is greater. As we can see in this case, 4 is greater than 3. So 4 square or -4 square is 16, 3 square is 9. So 16 is anyway greater than 9. So here we'll put 16. Then since we're done with this number already, we'll move start ahead. Then we'll check start and end. So in this case again 3 is greater, so it will be 9. So end will come over here. Then again the check will happen. So in this case 1 is greater. So 1 will be over here. And then finally this will also move ahead. And then this finally it will be 0 and we are done. So that is how we got the final output array also, 0, 1, 9, 16 and 100, and that is what we got over here also. So this is how, using the two pointers by comparison of the element at the both pointers and then finding out the square, we can easily solve this question. So this is the approach and this is the algorithm that we are going to use. Now let's see what will be the code implementation for this. So we'll start with the code changes for this. As we know, we can take help of additional space. So we are going to take a temporary array for storing the output result, and that is what we have to return. So I'll just return that as output. Will be the same size as nums, or rather I'll just store this length in a variable. Okay, and then we need a variable to track the index of the new array, in which we are going to fill in the squares, the square values. So we can take this, call this as index, and since we are going to traverse backwards, so we can initialize this to the last index. And then the left and the right pointers. So left will be initially 0 and the right will be at the last. So with that, now let's start with the while loop. So while index, so how long will this loop is going to run? It's going to fill in from backwards from the last index till the first index. So it has to be greater than equal to 0. Then we have to start with our comparison. So the first thing that we have to compare is the absolute values. So we'll do if math dot absolute of what? The numbers, the number in the left pointer, if this is greater than or equal to the number which is in the right pointer, means at the last. So whichever is greater is what we are going to suppose is what we are supposed to store at the last position of the new array. Rather not the number, I mean to say the square of the number. So then we will do temp of index, which is the index is now at the last. So now we are going to store nums of left square. So nums left into nums left, because this was the greater number and we want to push the greater number at the last, like 100. 10 is greater than 4, so we are pushing it at the last. So once we have done that, now we have to increment the left pointer, because we are done with the number which is at left pointer, so we can increment it. We also need to decrement the index pointer, because now we have already filled in the value at the last index, then it has to go to the second last index. But that we are going to do later. We'll just complete the if condition, because that is going to be a common thing which anyway we have to do irrespective of the if condition. So we'll do else. So if it is not greater than equal to, obviously the nums of right is greater. So then we will put in, then we'll put nums of right into nums of right. So the square value of this we have plugged into that index value. Similarly, the right pointer also needs to decrement. So we'll decrement that. So once we are done with this, at the end we can now decrement the index pointer also, the variable also, because this is going to be a common thing which we are doing for both. So this is going to run till we have reached the first index. And finally, out of this loop, we have to return the output array in which we have stored it. So sorry, I should have named it as output and not temp. Okay, so with that, let's run this. Submit this. Okay, so yeah, that's all about this question, how to find the squares of a sorted array. Hope you guys have enjoyed the session today.